So it says a golf ball is hit and it lands. That's not right. A golf ball is hit and it lands at a point on the same horizontal plane, 53 meters away. So from here to here, 53 meters. Okay. The path of the ball took it just over a 9-meter tall tree that was 8 meters in front of the golfer. Okay, so 8 meters ahead. 8 meters ahead. It just took it over a tree that was 9 meters tall. So the path was something like that. Okay? Assume the ball is hit from the origin of the coordinate plane. Okay. Find the quadratic function that describes the path of the ball. All right, so let's see. Done. So what do we do? That's 13a. So what do we know? We know 2 points. We know it's at 0, x-intercept, 0, and 53. We know we have a point at 8, 9 away from the ball. So what does that mean? That means we can make the equation as a. What does it ask us? Assume the ball, find a quadratic function. Find a quadratic function. Any quadratic function. Doesn't have to be in standard form. So what do? You say a x minus 0, which is x, and x minus 53. Okay, that's going to be our general formula. Just rewrite it a little bit. F at x equals a x minus 53. All right, and now we find our value of a, and we know that at f at 8 equals 9, so at f at x equals 9, a times 8 take away 53, we end up getting, what do we end up getting? 9 equals 8a times, what's 8 minus 53? Well, 8 take away 53, get out your calculator just so that you don't make a mistake. I think it's 45. 8 minus 53 is equal to minus 45. Okay, so I can cross this out, becomes a 5. I got 1 equals 8 times 5 is minus 40a. And we got minus 1 over 40. Divide both sides by 40 equals a. So I have my f at x equals a negative a over, what did I say? Negative a. Negative x over 40, because a is x minus 53. X minus 53. Okay, so that's one way that we can write our quadratic equation. What is the maximum height of the ball? Well, the maximum height is between 0 and 53, right in the midpoint. So midpoint between 0 and 53 is equal to 53 plus 0 over 2, which is equal to 53 over 2 is just 26.5. Okay, now we substitute it in our formula. F at 26.5 is equal to negative 26.5 over 40, and multiply that by 26.5 minus 53. And if we pop that into our calculator, 26.5 divided by 40 equals 0.6625 times 26.5 minus 53 equals negative, oh, and by the way, that's negative. Oh man, let's fix that. And it's equal to minus 17.55625. And when we multiply that together, we get approximately whoops. Let's do that again. 26.5 minus 53 equals 26.5. Actually, I know that. Times 26.5 divided by 40 equals 17 point, let's just say 5. So the maximum height is 17.5 meters. Therefore, the max height is 17.5 meters. And finally, C. Is it possible to move the origin in this situation and develop another quadratic function to describe the path? If so, find a second quadratic function. Is it possible to move the origin in this situation and develop another quadratic function to describe the path? What do you mean by move the origin? Let's see. I guess so. That means he takes a shot from another angle. I guess you could move it back, right? If you moved it back, you could pass the tree, right? You could do this shot. Whoops. Let's go back. Let's do another shot from here. I guess, oops, why is it doing that? I guess you could do this shot. Oops, not that shot. Just shift it over, right? In which case, it's the same thing, except we do a horizontal shift to the left. It's a little harder question. I wouldn't expect you to do this per se yet. I wouldn't ask that on a test, but I'll show you exactly how you would do that, something like that. So this is the function. This is the function. Essentially what we're going to do is we're going to complete the square. So let's move this function. Let's move it and show you how to complete the square, really. Okay, so take that. So let's complete the square. So I have, well, actually, you don't even have to complete the square. Another way, because we have the maximum height, we have A equals negative 1 over 40. We found that, right? Over here. Up top. We have H is a horizontal shift. What's a horizontal shift? It's, where is the X? 26.5. H equals 26.5. And K is equal to, what's K equal to? It was 17.5. Whoops, why did I write it like that? Okay, so f at x equals negative 1 over 40 x minus a yeah, is it minus? Yes, it is. 26.5 square, that's h, plus 17.5. Now, how do I shift it more? Well, I just have to move it, instead of being at 26.5, 17.5, I just have to shift it over here. So I just have to change this value. So an alternative that will clear the tree, I can do the same function, x minus 20.5, right? 20.5 square, or 20 is good. Okay, why? Because I'm shifting it a little less. Instead of going like that, and over the tree here, essentially what you're doing is you're just shifting this over here. All of these are acceptable, right? You could even say, could you? Something like that. So any small shift in if you move back a few meters, you'll get a similar shot. Now I'm assuming it's the same shot, not the same landing point. And then plus, I'm not done. We forgot plus 17.5, but there'll be multiple answers for that. There could be a lot of different answers. All you have to do is find something that'll clear the tree at that point. That's how you do question 13.